computer, so I'll be recording using, I'll be recording these lectures. Yeah, don't worry about the, I'll talk about the Runestone assignments in a bit, because this course does have a few moving parts to it. But I assume that you're fine with that, with the caveat that you're not having to pay for a service. So, or a textbook or something. So, all right. So if you made it here, welcome. This is CIS 1051. This is Introduction to Problem Solving and Programming in Python. Hopefully you got my announcements over the past couple of days. I'm gonna go ahead and sign off of Discord for right now. Which brings me to a point that we do have a Discord server, and you can find the link right here if you haven't joined yet. That is a very quick and easy way to get a hold of me, because whereas like emails, I assume are important, and therefore I avoid them maybe until I deal with them all once a day. Oh, really? Did it say?
I mean, it doesn't really matter because I knew that I had this today. So as soon as I saw CIS today's lecture, I clicked on it, but I was like, wait a minute, that's not the right number. I'm nowhere near advanced in coding enough for that.
Yeah, let me go ahead and send that out. Yeah, because I do two classes, or two lectures today, one of which is, and it just auto-filled. And I think it was just I was almost on autopilot again. So today's.
I was gonna say the first day we get a final. Wow.
Yeah.
That was a quick class.
Yeah. So there.
And then we're done. We have one day of class, and then we just go away. Like that's it.
Bye, y'all.
So, for right now, feel free to join the Discord. So this class, just to reiterate, it's intended for people who have no or just a bit of programming experience. And if you, if this is your first time exposure to coding, that's great. This class is for you. So it might seem like a lot at first, but this first week is basically just making sure we can get set up and working in Python and making sure that you've got the appropriate technology. So with that in mind, I'm going to go and open up our syllabus. I do have to make one slight change to the syllabus to fix that, because I had the wrong day listed for one of the labs, but that's but if you followed your schedule, you're fine. Okay, so why is it in here? I don't want to do it like that. So download. Now open it so I don't have to deal with it embedded. There we go. All right, so we are holding this virtually, and you sign on to this lecture. You figured that part out, great. It's also flipped, which means that for the most part, you're going to be watching videos that accompany the textbook and working through the textbook in preparation for activities that we're going to do in class. We do a lot of activities in class, just so that we can get some good experience in. There's a link to the Zoom, our Zoom, our Discord, and our lecture recordings listed over here. But let me go ahead and just emphasize this part over here. So uttering some variation of the phrase, "I did not know we needed to demo our assignments to receive credit after the first exam," will be grounds for an instant F in the course. So because you did not read the directions on the first in the first page of the syllabus, and that can be bad. That's my only really mean thing that I ever do. And nobody's ever nobody, now that I've had this phrase in here, nobody's ever made that mistake. So that's been good.
I have a question.
Go ahead.
What does exactly demoing entail? Because
Excellent.
I had the lab this morning, and they're talking a lot about demoing, and I was just kind of like,
Oh,
I
excellent
don't even
question.
know really what that means. I have zero background in any of that.
So no, that's a great question. It's something I do for my class. And what it gets down to is that it started as a process because downloading 150 students programs and executing each of them was an extremely time consuming and irritating process, especially when they didn't work, or even worse, in Java, it needed to be an exact file structure that you did not know until you downloaded and opened the file. So that was a bit of a pain. So the demoing process is that you come to me during office hours, during the lecture, or during the lab period for your TAs, and you show them the work you did. This allows us to do two things. First, we get to ask you questions about it and make sure you understand what you wrote, but it also allows us to kind of, if you misinterpreted something, we can tell you to go and fix it, and then you don't get heavily penalized for it. So it's just basically the way you, so what it is over here, you submit your homework, and I'll go over what the homeworks are I'm talking about. That's specifically, in this case, the labs. And then to demo it, you just show us or the TAs during labs or office hours. And that will get you your final grade. And it's basically just making sure, I'll just basically ask you some very basic questions to make sure that you understand what you wrote. All right. That answer your question?
Yeah, thank you.
I have a question.
Sure, go ahead.
So we just like once we do the homework, we just show it in the lab when we have a lab once a week.
Yes, or during office hours, either to me, the TA, or one of the TAs.
Okay, thank you.
Mm-hmm. Okay, so right, just be aware that we do have a pandemic going on, as if you didn't know, right? So everything in the syllabus is subject to change, including everything shutting down again, and all of us isolating and doing sourdough bread again. So you know, this again, as I said, is a introduction for both programmers and non-programmers. But it does mean, since it's a 4-hour course, that does mean that you're expected to do about 8 to 12 hours of work each week outside of lecture. It's a skill-based course, which is to say that some people, you might look at some people in this class and get discouraged, like they understand everything. That's probably because they have prior experience. It's not because anybody's a natural at programming. They're not. You're a human, and you're hardwired to be illogical and to have your mind work in specific ways. You are going to want to read things a certain way, and you're going to assume that what you're reading is what's there, when in reality you typed something else entirely and are misreading it the entire time. The only way you can basically get better is by practicing. So my intention is to give you ample opportunities to practice in a supervised manner. And I found that with students who basically fall behind, it becomes very, very difficult to catch up, because it's not just a matter of completing the assignments, it's a matter of practicing and figuring out how to fix the errors you make. You're going to make errors, you're going to feel like an idiot. But you're no more an idiot than any other human on earth. The difference between, and I'm going to constantly say this, the difference between me as a programmer and you as a programmer is that I failed a whole lot more than you. I failed a lot. I've made a ton of mistakes. My programs have broken. I've had to start from scratch again. I've had to retake courses, so I have made mistakes, all sorts of mistakes, but it just means I'm really good now at this point at spotting your mistakes and fixing your mistakes. Okay. It is only by basically by making mistakes is the way to do this, is the way to get better. You have an online lecture. Some of these of our labs are online, sections 4 and 7, and I think I misplaced that 7 was online on Friday, it should be online on Tuesday, because I just assumed that if it was on 7, if it was going in order, it would also be on Friday. But no, alas. Oh, right, and I forgot to remove this bit. See, the syllabus already has to be fixed. Okay. So, all right, so a reliable laptop is strongly recommended. Simply put, if you're using your laptop makes you angry, you're gonna hate this course, and not because of me, but because your laptop is giving you with difficulties. Part of the reason I try to keep the course cost down by making sure that we have a free textbook is so that you can have the opportunity to get a laptop. If you have trouble getting a laptop or you need a new one, please schedule office hours with me so that we can discuss possible solutions for you. A good laptop can actually be gotten for like around $400 these days. With that and $450 if you're not looking for something on sale, and it would serve you well. So and laptops would have a webcam and so all that stuff. So our textbook is an online textbook. I'll go into it in a bit more detail in a bit, but you sign up by going to runestone.academy, and you'll enter this code when you're signing up, which I'll show you how to do. If you need additional references, I've got 2 more free textbooks for you, both of which have a hard copy that you can purchase for around $20-30 because again, you know, textbooks are expensive normally, and I don't like that, and I hated that, and I'm doing everything that I can do to change that. So, and then the Python the official Python website has its own documents and tutorials, which kind of assume a bit of programming, but they're useful for referencing once you get started. All right, so office hours, right? So because for some reason not everybody knows this. An office hour doesn't mean this is a time for me not to be disturbed. It's a time for you to come and visit me, typically in my office, except that we're again in the middle of a aforementioned pandemic, and I don't want your germs. So, and I'm sure you don't want mine either. So I'll be doing my office hours virtually. I am on campus from basically from about, I think 8:30 to the end of this class on Tuesdays and Thursdays. So because I do have a class in the morning that I teach here. So those noon office hours I hold will be done in my room, but you can click here to book them. But I figured out yesterday that I can just embed it, and I'm very happy about this. I can just embed these office hours right here. And so you just simply select your class, and what that does will get you your thing. And the not available just changes based on the day you select. And that will allow you to book office hours with any of our TAs or me. So we have tons of slots available. And if you just want some general advice, you can just select general advice to just meet with me, which to discuss just general things about computer science, not necessarily related to class. And that just lets me know that it is a different kind of conversation. So now, mind you, these are just simply the set times I have set aside for you to meet with me. This doesn't mean these are the only times you can meet with me. If none of these times work because you work, just or have classes that conflict, just send me an email and we'll figure out a time. Okay, same goes with all of your TA, with any of the TAs. And by the way, you do not have to schedule office hours with your TA. Okay.
I schedule with the dog.
I tried to get the, well, you'll have to send an email to Happy Feet then. So. Okay.
I was going to ask you for an explanation for that, but I think it's better unexplained.
She's a very good grader.
I tried to find Happy Feet on Rate My Professor. Must be a new teacher.
All right. So, now what I do for my graduate course, because I'm my own TA for that course, I don't have a TA for that course. I just simply list myself as my own TA.
That's kind of funny. Is that an older picture of you?
Yes, it is.
Everyone have long hair in college? Is that like a law?
Graduate school, I think.
Okay. Because that's when my dad started growing out his hair in college, and now it's down to his back, like all the way down. So it's like, I'm trying to figure out if it's a law or something that you have to grow out your hair in graduate school or something.
Probably. It's just one of those things that happens. So, all right, not that one, this one. All right, so expectations, you're expected to attend, but obviously if you're feeling too tired to attend or you're sick or something, right? You know, just let me know. If you can't make it because like life happens, just let me know. The more, if you're honest and open with me, the more, you know, accommodations I can make. If you are or suspect you are sick, even if there's like an exam or an activity scheduled for that day, don't come. Just send me an email. You'll make it up. It's fine. Right? I want you to stay healthy and stay alive. Okay? That also, remember, you do have a certain number of days. If you have not been vaccinated yet, you need to get vaccinated. I'm not sure what's going to happen if you don't get vaccinated, but honestly, you should, because it's going to help keep you safe. I won't lie. I got the Moderna vaccine. The second vaccine, I had a fever for about 4 hours, 8 hours after I got it. Wasn't great, but I mean,
Didn't have to go to the hospital though.
exactly. I didn't have to go to the hospital, and considering
Because my friend.
sorry.
Sorry.
I've
No,
had
you go.
multiple.
This is your class.
Yeah, I've had multiple issues with the flu, with influenza, that just lays me out for about a week. So yeah, if I can just simply avoid that, that's good. If you have mental health issues during the semester, which just means that like you get stressed, depressed, again, life happens. Feel free to let me know. I'm not a mental health professional, but I am a pair of sympathetic ears. And also, like, the sooner you let me know that something has happened, or like your living conditions have changed or something, the easier it is for me to accommodate you. It's much easier for me to accommodate like issues that happen in the middle of the semester if you tell me in the middle of the semester, rather than telling me at the end of the semester. If you tell me at the end of the semester that you've been having half a semester's worth of trouble, that's a bit difficult. Okay, now with ongoing like accommodations, like if you need extra time on exams for something, or you have health issues that do prevent you from coming to campus, long term, the people to contact are DRS, Disability Resources and Services. Okay, they will tell me what accommodations need to be made. And once I have that letter, you can also tell me if there's anything else. I have yet to find an accommodation that is unreasonable. Okay. So, let's see. I will be recording these. You are allowed to record these as well, but you gotta let me know, because that's the way Pennsylvania law works, I believe. So let's talk about the grading, because this is where we talk about the textbook and the like. So, and let's go from the top. So solo exercises, that is 10%. So what the heck is a solo exercise, right? I've got exercises, and that sounds a lot like homework, and kind of is, but all right. So let's look at our textbook. So what you're going to want to do to sign up for your textbook is you're going to hit the sign up button over here. You create your own username, type in all this information, and then under the course name, you type in Fall 2021 Rosen. Okay. That is the one that will sign you up for the course and register you as a student for me. Creating the course will not give you like, the answers or anything for this. So, I mean, feel free to try though and experiment, but I mean, like, it's not necessarily going to give you any more information than I have. So once you do that, you'll be registered for a course, and see, so I can log in and you'll hit 2021 Rosen. You'll just have like a lot less courses, and that'll bring you to our textbook. Okay. So there's and this is, it's electronic, and I really like this textbook for a couple reasons. One is that's meant for active learning. All these projects that we can do. Also, right over here with this edit button over here, has some, it's got a built-in Python editor, so I can literally write some code right here. This is one of the first things you'll be learning in the lab and in the next couple of days, which is print, which simply says print out this word. And now I can run it straight in the browser, which is great. There's a lot of browser-based options, so even if you're using a Chromebook, you'll be able to do some programming. Okay. So let's see. So now over here, now I'll link to these are also linked on Canvas. Okay. If we go to our modules, right, and I go to the module 1 overview, you'll see that these exercises and readings are linked on Canvas as well. And you'll see that basically chapter 1 readings, I got some questions about this with chapter 1 readings. It doesn't have like a button to grade you or score you. That's because I was messing around with it earlier to see if I could integrate it with Canvas. And I ran the grader. And when I run the grader, those buttons disappear. So I'll run it again at the end of the week and you'll get your credit for it. So don't worry about that. So the way these assignments work is that you can type in these questions, right? So let's go over here. That is 25. So I'll do check me. Number 1 is right, it says, and I can do score me. And it says, okay, I got that one question right out of the 42 points I need. So the thing here is that this score me button is just kind of a self grade. It doesn't actually tell you what your grade is. It's just simply saying, this is what the auto grader will give you for your grade, if that makes sense. Parasite was great. So, okay.
Can you just distinguish again the difference between check me and grade me real quick? Thank you.
Check me just simply runs a single question to tell you whether or not you got something right. Score tells you what the overall score is going to be.
Great, thanks.
Okay, so
I also have a question.
Sure.
So if we get something wrong, like would we be able to like go back and redo it to get points for it or no?
Excellent question. You are allowed to try this as many times as you want.
And we'll still get full credit for it?
Yes.
Okay, cool.
Yes. So that is so now that I've explained, so the textbook is the solo exercises. Now, I call them solo exercises because they're meant to be done by yourself, and the due date for these are a soft due date. If you run late on them a couple days, your grade will get updated the next time I run the grader. Okay. But this is just basically this is to keep you on track and give you a way to earn points by showing that you understand the material. Each of the questions are short, they're targeted, they're intended to be done without necessarily having to ask questions, but feel free to ask questions because some of the questions I've chosen in the past have been from the textbook have not been straightforward and I didn't realize that. So just let me know, right, if there's issues, but the point being is that they're not meant to drive you insane. They're just meant to make sure you understand the concepts, okay, and that you can do them by yourself. They can be done unsupervised is the point. All right. Our active learning exercises are basically things that we introduce in the lab or in class. So they refer to the projects that we're going to do in class, which you'll probably be finished at the end of the class, or the lab, which are longer things that can be will mostly be finished in lab. All right. So we can talk about anime later, but let's keep focused on class, people. Okay. So with the active learning exercises, we have to we basically they will be guided by the TA or the instructor, which is me. And there will be basically a live walkthrough or recording. So we're going to see that on Tuesday. where basically that we will go over our first active learning exercise. So Thursday, we're going to do our first, active learning exercise and get credit for it. And a big part of this is that, again, I encourage you to work with other people. Okay. Your labs, the labs themselves are unique because you have to demo them. But for the other stuff, if it's done as part of the textbook auto grades it, so you don't need to demo it.
I know this may sound like a silly question, but what does demoing mean?
So demoing means that you've got a two-part process to get a grade for the labs. The first is to submit it onto Canvas so that you prove that you've turned it in at this time. And the second is to show it to me or a TA, and run it. We can confirm it works. And we can also confirm that it works in the way that we intended it to work, because sometimes students make a misinterpretation and we need to correct that. I try to be as unambiguous as possible, but sometimes there's still some confusion about what needs to be done. Okay. So demoing allows us to correct those mistakes as they happen. It also allows us to basically really check off and ask you questions. So if you worked with somebody else, which again, I highly encourage, I can make sure that you understand it and you didn't have somebody else do it for you.
Is the textbook free, or do we have to pay?
It's
a
free.
fee
It's
for it?
free. It will ask you for a donation to help with their server costs.
Okay.
But once you do sign up, it won't happen again. Quick question about the solo exercises. Yeah, again, don't worry about the solo exercises saying that I will run the grader again and it will update your grade for those. Okay. So we also, during COVID, I also started doing a final project, which is worth 10% of your grade. And a big chunk of the latter third of the semester will be dedicated towards working on a final project. This is largely a self-guided project. It is okay if you come up with an idea and that idea just completely falls flat on its face. But it's really, I'm interested in seeing what you ended up doing and what problems you encountered with it. If you're like a senior or a junior and in a higher level class and you've got another class that's project oriented, you are not only allowed, you're encouraged to double dip. You're allowed to basically say, okay, can I try to do a final project for my other major and combine it with this one. So the only caveat to that is that you have to get permission from any professors that you have to do that. How do you submit the solo exercises? That's the brilliant thing. This will automatically save after you run Check Me. So it will automatically save as you work on it. So you don't have to worry about submitting the solo exercises. It will, as long as you're running your code, it will save every time you run the code.
Will we have points deducted if we click Check Me and we're wrong and then we correct
Nope.
it? Okay,
No
thank
points
you.
are deducted because you get unlimited attempts, right? Watch over here. I did the first question. I hit Check Me. Check Me just simply checks to see how it's done. Are your answers correct? So notice it says 1.0 out of 10. So let's go over here, 45. I'm gonna just run this, Check Me, got question 2 right. Notice the grade did not update over here. Check Me just tells you whether or not it's right. Score Me tells you what grade you are going to get. That make clear?
Yes, thank you.
So if we hit score me, we can't do it anymore, right?
Sorry?
If we hit score me, then it's done. You can't do it again.
No, I just did it again.
Oh, okay.
Yeah, I just ran it again. The only caveat I will mention is that you might get worried when I run the grader. The score me the score me button will disappear, but don't worry about that. Okay. When I run the grader again, your score will update. And that's only the students, and that only really is an issue for if you fall behind. Okay. So I'll go into more detail about the final project as we get closer to it. but it's a group project. You can work in any language, infrastructure, or anything you want. And you're allowed to work in groups. The prize I give to motivate you for doing well is that the 3 groups that do the best. Actually, since we have 6 sections this time around, let's go with each lab that does the best section will be excused from the final exam. So in other words, if you have the best section in your lab, you don't have to take the final. So there's your incentive to try your
Best section? What is
the best project in your section.
Okay, got it. Because I'm like, each lab it's its own section, so I'm confused. All right.
The best. Yeah, I misspoke. Okay. So quizzes and exams, I'm trying to figure out because I was doing them online earlier in the semester, back in spring. And now I have all these labs that are all spread out, and some are online and some are in person. So I'm still figuring that out. But the point being is that you're going to have timed assessments. They're going to be frequent. They are going to be open book. And you can use any and all non-human resources during the test, but the only other humans you can talk to are us. 3 people are the max in a group. The quizzes will be announced. I do not like pop quizzes. Yes.
Will the final also be open book?
Yes.
Okay.
And, I mean, what it comes down to is I'm not going to pretend that resources like Stack Overflow don't exist. Okay. I'm just got to figure out what I want to do with the final, with the quizzes. You'll know by the end of the week about how I want to do that. Because last time around, a lot of the quizzes were unproctored because trying to proctor 150 students is kind of a losing battle here, even using Proctorio. So how do you study for the quizzes? I will let you know what they will be covering. Okay. But again, they're going to be short and targeted. Stack Overflow is a very popular website for getting answers about how to do things in computing. Not necessarily like homework things, but like how do I like read a file in this language properly? Yep. Oh yes. So if you use any outside sources, and I'm going to get into the academic honesty stuff, but in general, if you go through and if you find something online and you cite it, in general, that's great. That's citing. I like it when you cite. Oh yeah. Okay, I'll go in more detail about that. Late policy. So my late policy for my quizzes project will have to be updated because depending on how I plan on doing the quizzes. Again, I'm just trying to figure this out mechanically now that we're kind of in this weird hybrid. Some of us are online, some of us aren't for our labs. Are we doing data structures in this class? I mean, we're going to be using lists and dictionaries, so yes. But actually learning how data structures work is my other class, which is 2168. So, and if you're interested in learning more about that, I'm happy to answer all your questions about that. Okay. Yes, so yeah, if you want to cite something, the way you do that in compute, and I will go over this again. The way you do that is to do a comment. And if you don't know what that is, right, that is something you will learn. Okay. So late policy. Late assignments, I have a penalty of 5 points per day. I want you to do your assignments even if it's late. I don't want you to suffer staying up all night trying to get it. So take the 5-point loss. And if you fall behind, maximum penalty of 50 points. You can still turn you can still turn in your assignment for 50 points. Okay. The late grades are determined by when you turn it in, not when you demo it. So if you turn it in right on the due date, but you don't like demo it till next week, perfectly fine. Static methods and class methods, that's more object-oriented programming. Yes, this lecture will be posted in lecture recordings. Now, I do have this clause here saying that you have up to 2 weeks after the due date to demo your lab. That is a flexible thing, but in general, I have that in there so that I can say no when a student doesn't demo all their things the entire semester and tries to turn them all in, all at once. Yes, you can work ahead. I'll be working this week to try to post to fix the dates. Everything in Canvas, almost everything in Canvas is stuff we're going to be going over. I just have to fix the dates and determine from last semester what I want to change. Okay. And then I also have to link the things for the solo exercises. Okay. For the final project, that's it's got a much more strict late penalty of like 0.1 point per minute late. And depending on how we do quizzes, that could apply to the quizzes too. I will go over that in more detail once I figure out how we're going to do the quizzes. Yeah, you can always resubmit an assignment to try to do better on it. All right, so let's talk about the academic honesty policy. Okay, because this came up in spring semester because I allowed open internet as well. Because, I can't really monitor your screens as you're working and trying to use Proctorio. I don't like the idea of a service that gives too many false positives. I knew I have a friend who who suffered academically because a TA accused him of cheating, and he's not the sort of person to do that. So those kind of false positives are there. That said, I had to write up between 1051 and my other class, 12 academic dishonesty reports for the spring semester. That was not fun. If you're not sure if you're supposed to be here, you're supposed to be here if if you are assigned up for 1051. Okay. So I use, if you cite okay. So Emily, you brought up a great point, which is that if you're citing it, by definition, you're not being academically dishonest, are you? Right? The point about this academic dishonesty and plagiarism is that you didn't cite your work. The worst I can tell you to do at that point is do it again or give you a 0 on something because you didn't do it yourself. But never an academic, but never like a report because you didn't misrepresent your, you didn't cheat there at that point. All right. So first, let me stop playing bad cop for a second. Okay. The best way to learn computer science is by trying to teach other people. Or rather, the best way to master it is by teaching other people. And I really am a big believer in making sure you collaborate. Okay. There is that line between getting help from another person and turning in somebody else's work. So I want to make sure that I characterize that. So if you feel like you made a mistake, let me know within 72 hours and I'll probably be a lot more lenient. Okay. So what are the things that I consider reasonable? All right. Talking to your other students, perfectly reasonable. Doesn't matter if it's in English or any other language. Okay. Discussing the materials with anyone else outside of this class, perfectly reasonable. This is the big one. Helping somebody figure out a bug in their code, in person or online, by looking at their code, compiling their code, running their code, even if it's on your own computer, right? So in general, when is it okay to share code with another classmate? If you are the person if you're sharing the code and saying, I have no idea what's going wrong, please help me. That's where it's okay to share your code. As I'll show you in a bit, when it's the other way around, when somebody says, I have no idea what I'm doing, can I see your finished homework? And you share your finished homework, that's where we get into trouble. So even in Discord, it's perfectly fine to post the code that you're currently working on and saying, I have no idea what's going on. Can somebody help me with my code? Here's the lines that are giving me an error. Perfectly okay. More than happy with that. Okay. Incorporating a few lines of code you find elsewhere, online or elsewhere, into your own code, provided those lines are not themselves solutions to the assigned problem and you cite them. So in other words, you know, if you find a line that a couple lines of code from Stack Overflow that help you finish a bit of a piece of the problem that you're working on, that's great. If on the other hand, you find something on Stack Overflow and it solves everything for you, I'll probably ask you to do it yourself again. Okay. Yeah. So sending or showing code to some, and also note the fact that you cite the line's origin. And again, the way you do that in the way you cite code in Python is you do it in a comment. And a comment is just simply the hash symbol in front of a line. And then anything after that, the computer will not read. We will go into more detail about this in the coming days. Okay, sending or showing code that you've written to someone that you've written, possibly classmates, so that they can find a bug. Putting that online on Stack Overflow to help find a bug. Looking anywhere for that. Although I strongly suggest not going to Chegg or like any of the other like homework helper websites, because they are terrible, and not like in a moral stance. I mean, like they are objectively, they have given objectively wrong answers. And I know this because I've had experience with students using that stuff. Okay. Whiteboarding, great way to do stuff. Working with and even paying a teacher, a tutor, highly encouraged, so long as they're not doing it for you, right? So what is not cool? Like using somebody else's solution from a previous semester and just turning it in as your own, getting a code, getting your friend to send you their code, changing a couple variables and then submitting and get on your own. This is not really relevant to this class, because I don't give you compiled code in this class. Failing to cite the origins of codes or techniques you discover outside the class. So there's two examples. Finding code online that addresses a question on an exam and failing to cite it would violate this policy, right? And I put these in here specifically because of spring. Finding code online that you think might address a question at hand and then blindly copying it into the exam when it doesn't actually address the question is a great way to violate this policy and make me angry. So that is kind of my pet peeve, when people copy paste code and they have no idea what it does. Okay. So for context, what happened in spring is that my final exam is actually very short. It's only 3 questions. Those questions have a lot of parts, but it's only 3 questions. One of the questions was, here's a game, I need you to run a Monte Carlo simulation of it, which is just simply saying, imagine a game like Candyland, where the outcome is fairly easy to calculate. You know, you just write up the rules for the game, simulate the deck and stuff. This is a bit it was similar, but simpler. And so basically just tell me how the outcomes work. Well, the issue was, students Googled Monte Carlo game name, and they came up with found a Monte Carlo approximation done by a professor, but it was for a different version of the game, with different numbers of pieces. And it was using extremely advanced coding techniques, like using lambda expressions. And that was just a mess. So they submitted I had multiple students submit code for the wrong version of the game, and it was all the same wrong version. Oh, sorry, all the same code. So yeah. So giving or showing a classmate to a solution to the problem set when it is he or she and not you struggling to solve it. So if you're the one basically if you're the one struggling, you're the person who's allowed to share the code, okay? The other one, yeah, paying for somebody else to do it, obviously not great. Splitting up the workload, saying you do the first 3 problems, I'll do the second 3 problems, you know. Just changing a couple of variable names, it's not really gonna work. In general, if you're struggling, please just come to me and speak to me. I will help you. I will give you extensions. I will sit down with you and make sure you understand it, because that is literally my job. Okay? If you are struggling, I'm not going to think you're stupid. I'm going to think you're a student who's having trouble just wrapping their head around a new concept. Yeah, you can totally DM me on Discord. Students do that all the time. Send me an email, DM me, whatever. Yeah, debugging websites are okay. Okay. All right, so right, and because I cite things, I totally cite the fact that this certain things of the syllabus came from the CS50 Harvard stuff, because they had some really good stuff that I felt there was no need to rewrite. Do I have a schedule for exams or quizzes? No, I will let you know. I will always give you at least a week's notice before before a quiz, though. We will see. I'm still trying to figure out the quiz situation. It will probably be 45 minutes because they're going to be super short as opposed to normal exams. Yeah, running and debugging can take a long time, but I'm hoping to, like, again, I'm trying to utilize Runestone as much as possible to allow for auto grading and and to deal with those kind of things, if that makes sense. Yeah, there's always partial credit. So I will tackle those, but so it's going to happen one of two ways, which is that you do them unproctored, but I don't like that idea. The other way is that they'll probably be handled in your lab section, and you'll have 45 minutes, and then you'll have a slight penalty if a very, very, very slight penalty if you're going over time, if that makes sense. The only issue with doing it in the lab is that there's the issue of cross communication between lab sections. So that's what I'm trying to figure out here. But honestly, part of me is just inclined not to worry too much about it. So, all right. I should know I should have it figured out by Wednesday what I'm going to do. Okay. So that is our syllabus. Any questions about the way the class is going to be run? I try to make it so that everything is able to be found on this front page. Any recorded lectures will end up here in lecture recordings, which currently has the previous semesters there. So, yeah. And let's see. So in general, you can find what you need with the modules. This week, we're focused on installing Python on your computer, getting it up and running, configuring your idle if you're using idle. And I mentioned that. So what is idle? So to interact with a programming language, you need some kind of programming environment to work in. You could ostensibly do it in Notepad, but that sucks. But so we have these various tools to do this. One that comes prepackaged with Python is idle. I like it for beginners because it's minimalistic. It doesn't have any extra buttons or anything that looks scary. It has some autocomplete features, which is great. It comes prepackaged with Python, so that makes it very easy. As far as what you want to use, if you are experienced and have some experience in with another programming environment, such as Microsoft VS Code or GitHub Atom, wonderful, use that. I don't care what tool you use, so long as it works for you. I will be switching to VS Code later in the semester because I like it. But in the beginning, when everybody is when all the beginners are going to be using idle, I'll also be using idle. Okay. So and if you're using something like Atom or Python, Atom or VS Code, you're still going to have to download Python to get it onto your computer. It's just that installing a second IDE might have to be another step. IDE, Integrated Development Environment. So there's a lot of different, basically it's a program you can do a lot of coding in. Some are more powerful than others. There are some though that I consider a bit overkill. You can still use them like PyCharm. PyCharm does a lot for you. It's amazing. It's super strong. It's powerful. It also looks really intimidating for a beginner. But if you've used it before or something like Spider, go ahead, use it. More power to you. Okay, so now if you are working off a Chromebook, this might, or an iPad, this might be a bit difficult for you because, you know, it can't really install Python necessarily on that. If you're on a Chromebook, of course, you can like install Linux or something like that. You can, but that might be a bit scary for your first time. So over here, I have a video on how you can do on web-based programming options for CS 1051. Okay, so in other words, and this is from last fall, but basically it's a way, it's how you can do coding in your browser. And there's various different options. Worst case scenario, if you're trying to scratch something down, you can always use this editor and, you know, download what you have there. But I don't necessarily recommend it, but it is a useful tool to have just for writing things. But there is just essentially web-based IDEs these days because everything is on the cloud. Okay. So, if you want to get ahead, go ahead and take a look at Module 2 and Module 3. The videos are going to be the same, but the dates haven't been fixed from the spring semester, so just keep that in mind. Okay. So with that, I'm going to use the remaining time we have to kind of just talk about what is it exactly this class actually about. So in computer science education, we have essentially 3 kind of core courses that you have. Okay, or 3 kind of steps that you have to go through in computer science education. The first is this class, the introductory class. And what we are trying to do in this class is give you exposure to programming concepts, but also give you the ability to basically take a problem that you have and automate a solution for it. Basically I have this problem, figuring out the solution is hard, make the computer do it. And just kind of going through and translate and figuring out those constructs for translating a problem that you would do yourself into something that a computer could do. For instance, say you are, you need to email everybody their unique username and password for the class that you just got assigned to, which is something I had to do. Rather than writing 30 emails, I wrote a program that I could just run once and sent an email to all the students. Doing things like that, or say you have these 2 spreadsheets that might need to be merged, something I actually do a lot for our grades. I have a program that merges those 2 spreadsheets together and makes sure and combines the 2 grade fields together. Okay, so there's a lot of things you can do there. The next step is, and some schools we split that also into doing object-oriented programming as well. The next step after that is what I also teach, which is 2168, which is data structures. Which is, okay, now that I know how to like solve problems, what if I've got problems that have a lot of data? How do I organize that data in a good way? And I mean that in an abstract kind of way. That's not necessarily like in the ones and zeros down to the hardware level. I'm talking about like if I were to like draw it out on paper, how would it be organized? Attendance is not something I take.
By the way, I just had a question about this citing because I just realized I was like thinking about like, oh, I should probably go back into my project then and actually go cite the source that I used. But then I realized it's a book. My dad found out, when I told my dad that I was going to be taking a coding course, he got me this. Can you see me?
No, I
Got
can't
me-
see you at the moment, but
Oh,
you
got
just
me
cite, so you can cite that if you're using a book, you can just cite the title, the author name and the title. That's it.
okay, cool.
So, and then the third course would be data structures and algorithms, which is really advanced problem solving processes. So what is computer science? What exactly is this madness that you signed up for? Computer science is a bit of a misnomer because that'd be like calling astronomy telescope science and biology microscope science. And I do have this whole spiel to talk about it, but I used a lot of time already. Computer science is the study of what can be automated efficiently. That's what we're asking. We're asking what can be turned into an automated process. Or as Gibbs and Tucker puts it, the study of algorithms. There is no like easy formal definition like biology is the study of life, you know. And computer scientists are argumentative folks who will all argue over different definitions, but all these people are everybody will say not wrong. And yeah, if you've never heard of everything that's going on in the chat, don't panic. Like I did, you are going to experience imposter syndrome like nothing you've ever had before, because you've got people who have had some exposure, some people who have lots of exposure, and like half the class who has no experience whatsoever. So don't worry if you have no idea what they're talking about. Oh yeah, imposter syndrome. It's the feeling that you're an imposter, a phony, a fake, and everybody else knows what's going on, but you have no idea what's going on. That is imposter syndrome. It is very common in graduate school and in undergraduates, especially common in
It's
graduate.
worse if you're a minority.
Yep, especially. So what is computer science? It is the study of algorithms, the problem-solving process. It is the way we look at algorithms and figure out if they're correct, if they're efficient, if they how to build machines that can run algorithms, programming languages for writing algorithms, and dealing with the issues that come up with algorithms. So there are all sorts of things you can do with computer science. Besides just being a code monkey or a developer, you can go into biology, chemistry, medicine, bioinformatics. That was big, right? That was big before COVID. It's really big right now too.
That's where my like very small amount of coding comes from, because they asked us to do a little bit when I was doing a lab in the summer. So like, yeah.
Yeah. So some experience we've that I've seen with these are, we've seen like stuff in the development of new medicines, like HIV inhibitors. A lot of those, any kind of new medication that looks to attack a virus, we'll be looking at, we'll be running simulations of different proteins and how they work. If you're thinking on the more robotic side, prosthetics. I mean, just simply augmenting humans with mechanical parts. Bioinformatics is the cross section of, so informatics is what they call computer science in other places, like in some European schools. So bioinformatics, basically biology and computer science cross section. Physics and astronomy, also an awesome cross section. Quantum computing, which I won't even pretend to know much about. But these days, like with the amount of telescope data that we're getting is huge. Most supernovas are first detected in the sky, not by human observers these days, but by basically taking photos via telescopes and then having computers detect them. If you are into lots of money, high-speed trading algorithms are where it's at. If you're interested in psychology and how humans interact with the computer, there's an entire cross-section in there. And we have some great faculty members who do human-computer interaction. That is the basically cross-section of psychology and computer science. That is in fact where I got started in my undergraduate research. Specifically, I started out in working on in a lab that developed user interfaces and acoustical maps for the visually impaired community. And of course, education. I personally love edutainment, which is an old word for basically all those educational games. So there's a lot of stuff that you can do with computer science that aren't just software engineering or data analysis or security. So I've been using this magic word algorithm, so we should probably define it. So the word algorithm comes from the Latinized name of Muhammad ibn Musa al-Khwarizmi. They took that and they looked at that and they said, yeah, it's algorithmic, which is insulting, but hey, that's Latin. So he wrote a textbook in 820. So that gives you an idea when the guy lived. You can go and look up his Wikipedia page. It's great. So he wrote this book called The Concise Book of Calculation by Reduction, and we get algebra or algebraic from its title. So this is literally the guy you can blame for algebra. He also wrote this book about this newfangled decimal system that was coming out from India, you know, using base 10 numbers rather than the annoying Roman digits. And that got translated it's back to Latin, and then that spread throughout Europe. So algorithms, because he wrote algorithms in these directions in his book about algebra and other stuff, it's named after him. So you already know a bunch of algorithms because you use them in mathematics. Anytime you do addition, you're using an algorithm where you're going from the ones place to the tens place to the hundreds place and adding everything up. That's an algorithm. Anytime you do long division, remember long division? Hated it. Okay, great. So we've all experienced that flashback together. But anyway, that was an algorithm. So algorithms, once we make them into a program, we can automate a task. Algorithms can look like this. This is not a computer program, it's an algorithm, which we could easily then translate into computer code. There's a lot of stuff that you probably don't understand in there, and that's fine. But there's some key features there. Notice that we have these line numbers, we have these indentations in here that kind of have these steps in here. This is how that program would look in Python, except that I would suggest using names that aren't terrible, because A and B are terrible names, as we'll learn up. Okay. So what is an algorithm? It's this big blocky definition I give. It is a set of well-ordered, unambiguous operations that yield some result in a finite amount of time. That's a lot to take in, so let's talk about it. An algorithm is well-ordered. That means that we have it goes step by step by step by step. So you're going to do step A first, then step B, and step C. You're not going to go step C, then A, then B, or however you want. It's a well-ordered. One thing follows another. Okay. Unambiguous. Okay. That means that basically there's no possible way to for a computer to misinterpret what you're writing. Your computer, your programming, when you're working in programming, it's best to think of your computer as an evil genie. He is going to listen to what you say and then do exactly what you told him to do, even if that's not what you intended. These operations are unambiguous. No room for misinterpretation. It yields some result. Okay, it does something in a finite amount of time. it does something before I die. You know, it does something in some amount of time that is, it doesn't go on forever. Okay. So some of my favorite algorithms, you probably know, are cookie recipes. If those directions are good enough, it is a set of well-ordered, unambiguous operations, right? Take these ingredients, mix them together, bake, preheat the oven to this temperature, put them in for this amount of time, take it out. Recipes are algorithms. They are well-ordered, unambiguous operations, right? You don't just throw the ingredients into the oven before you mix them. They have a certain order. True, Alex. Baking is a science and cooking is an art.
I'm a food scientist, I would know.
Mhm.
Yeah, that was a joke.
So, all right. So I'm going to scroll through this and give you a very, in the last 10 minutes of class, I'm going to give us a very brief history of computer science. Okay. Basically, as long as humans have been trying to do operations and add things together, we've needed tools to help us. The first such tool was the abacus, which is that clicky clacky thing with beads that we never learned how to use because they're obsolete, but they do make some very satisfying clicky clacky sounds. And so we love them. They're not a computer. They just simply help the human do all those operations for computers. Our first kind of computers started to come about, that first kind of process that we have documented, I should say, came about between the 1600s and the 1800s. Various people came across this idea independently. So it's not unheard of that somebody like 1,000 years ago could have thought of these machines to do this, and it just never got written down and preserved, right? Will you be quizzed on this? The only thing I would probably quiz you on is the question, what is an algorithm? But sorry, what is computer science? And the correct answer is the study of algorithms. I might also ask you about some of the historical figures I've mentioned, which is, I've only mentioned one so far, which is algorithmy. Okay. So that is, okay. So anyway, between the 1600s and the 1800s, the idea was to have machines that use gears, and the positions of the gears would somehow represent the numbers. And then you could operate on the gears and crank this machine, and it would do these operations, and they could, and so Pascal had this idea, Leibniz had this idea, Babbage had this idea. Babbage specifically, he wanted to create this gear-based machine, and it could put the output on paper. Okay. Which brings us to our first programmer, Ada Lovelace. Picture of her. So, which isn't what her name is, Ada, but everybody calls her Ada Lovelace. Technically, she is Ada Augusta Ada King, Countess of Lovelace. Okay. Now, she had a rather messy life because of who her parents were. Anyone know who her father?
Byron? Is that Lord Byron?
Yes, Mad Lord Byron.
If we're going to talk about history, we need to not, because my brain will break.
Well, Lord Byron, well,
I love history too much.
Well, let me just say this very briefly again. Lord Byron and his wife went through such an explosive divorce in the time that people were still sniping about it 20 years after their death. Okay, so anyway, because of all that drama, Ada was raised to basically stay away from the arts and instead devote her mind to mathematics, which she did. So she eventually began to work with Charles Babbage, who designed this analytical engine. He never managed to produce it, but the idea here is that this engine could take instructions from paper cards with holes punched in them and then can do numerical operations. So Ada compiled his notes, published a paper and a bunch of stuff on that. and then she added a program on the end of that could show how you could write a program for the analytical engine that could be used to compute Bernoulli numbers, which are the series of numbers which are useful in statistics. You will learn about them when you take statistics. They sound advanced, they're really not. But anyway, their other big contribution is she wrote about a machine that could be like the analytical engine, but it worked on things other than numbers. And for people wanting the name of the other person, it is this, Mohammed ibn Musa al-Khwarizmi, or Algorithmy. So you can just simply look that up on Wikipedia. So, so now that brings us to the other computer scientist you may know well, which is Alan Turing. So World War II was the birth of modern cryptography. Before then, in World War I, you could still ostensibly crack things by hand, but it was getting to be a very painful process. So the birth of modern cryptography, which was using machines to encrypt things. And then also breaking things. It's very interesting, actually. Anyway, so Alan Turing, Ultra was one of the classifications, I believe, of the German. Yeah, Ultra was the classification of the German intelligence that was captured via efforts. Alan Turing led a team, was part of a team of engineers that built a machine that would help break those things. Now, you may have seen The Imitation Game. I am very happy to say that Alan Turing was a much happier person than Benedict Cumberbatch played him as. However, he essentially was, he died at an early age because he was gay at a time when it was not acceptable to be gay. And he was given the choice of basically being imprisoned or being chemically castrated. He chose chemical castration and then eventually committed suicide. So yeah, and that has been a really just kind of, dark mark in British history. So especially since Eisenhower said that Ultra was decisive to an Allied victory, it shortened, by his estimation, it shortened the war effort by about 2 years.
Did you know that they just put him on a bill right now?
I did. They eventually, the British government eventually apologized, but it was still a bit of it's still a travesty. But otherwise what he's known for is what's called the Church-Turing thesis, which is this idea that him and a bunch of other people had about how to basically create, it was a mathematical model for a computer, which allowed us, and because we had a mathematical model, we could prove what computers could and couldn't do. I can upload this document onto the files and send it out. He did make the Turing test, I believe. Now, there's been a bunch of other things that have gone on in computer science since then, but the name of the game has been globalization and miniaturization. First computer, no clear first, but ENIAC, one of the first ones, which was used for artillery calculations, 1,800 square feet. My phone is a more powerful computer than that, and I treat it like crap. So the first personal computer was introduced in 1981. Computers started getting interconnected via a World Wide Web, which is a giant net, which is an application that runs on the internet, which is a collection of computers all networked together. The web has gotten so big that you need a search engine to find stuff. You need to use a program to find things that are on the internet. So And again, things have gotten smaller and smaller and smaller. The point that basically that a lot of computing is done on phones these days. You just, yeah, the only homework we have is the electronic text. Yeah, so it's 3:17, so I'm going to go ahead and wrap up. I will post this on our files. But the two important figures are Algermity and Ada Lovelace. I put less of an emphasis on Turing because he's got a bit more of a cultural oomph. I mean, there's been a movie made after him. I mean, if you're more interested in that time period and you want something in a fictional and entertaining perspective, this book over here on Neil Stephenson's Cryptonomicon is pretty good. If I were to quiz you, it would be from that, I would quiz you on one of three things. What is an algorithm? Who is Mohammed bin Musa al-Khwarizmi, or who is Ada Lovelace? So those are the three things I would know if I were to put any of that on a quiz. Okay. So what do you need to do for this? What is the work you have to do? Complete the readings and exercises in this book by Sunday. I'll get you more details about the quiz on Wednesday. I'm still trying to figure out how I want to run my quizzes for this class. Ada Lovelace. Probably not next Wednesday. I'll figure it out. Like I said, I still have to figure out what I'm doing for my quiz. I have to, I will let you know. It will not be super scary. Okay. And there's going to be lots of quizzes. Why is the work on the e-text? Because the e-text will auto-grade it. Oh, yeah, you just simply click the link and it will take it to you. Take you to that, which is read the chapter in the text, read the chapters in the textbook, and do these very short exercises. If you've already been to lab, then you've probably done the lab you need to do for that. But otherwise, you know, if you didn't finish it or haven't gone there yet, the lab as well you need to do. And then, yeah, and then we'll do a active learning session on Thursday. Okay. And how do I get points on the reading? I don't see the score me button. I'll run the grader. That's how you get your points. I'll do that at the end of the week, at Sunday. All right, so that is that for this class. Let me stop recording.